One useful tool in science is what we call dimensional analysis. Dimensional analysis allows one to check their calculations, verify the equations used, etc. In mechanics, dimensional analysis is going to be based mainly on three quantities: length, time, and mass. Length, the SI units for length is meters. And in the dimensional analysis, we refer to it as L. The SI unit for time is seconds. And in the dimensional analysis, we refer to it as T, capital T. And the third quantity is mass. The SI unit for mass is kilograms. And the dimensional analysis symbol that we use is capital M. Now, when we look at other quantities that we use in mechanics, for example, velocity, the SI units for velocity is meters per second, that we can rewrite as meters second to the power minus 1. To the power minus 1 tells us it's in the denominator here. In the dimensional analysis, that's a length for the meters, and then 1/seconds, that's times time to the power minus 1. Acceleration is meters per second squared, that's the SI unit. That's meters s to the power minus 2, which is, in the dimensional analysis, L times t to the power minus 2. Forces, for example, we'll see very soon that forces have the same unit as the product of mass times acceleration. Acceleration, we just saw that it is meters per second squared, and mass is in kilograms. So the unit for force, which we call newtons, is actually equal to kilogram meters per second squared, which is, when we rewrite it, kilogram meters seconds to the power minus 2, which is m for mass, L for length, and t for time to the power minus 2. Energy or work has the same unit as force times length, which is newtons times meters. We call that actually a joule. And newtons times meters is kilogram meter squared per second squared, which is kilogram meter squared seconds to the power minus 2. Mass, length to the power 2, time to the power minus 2. That's the dimension in dimensional analysis. Power, which has the SI unit watt and written as capital W. It has the same unit as energy over seconds, so newtons meters over seconds, which is, if you do the calculation, kilogram meter squared per second, so it's kilogram meter squared per second to the power 3, so which is kilogram meter squared s to the power minus 3, which is m for the mass, L squared for the meter squared, length to the power 2, and for the second to the minus power 3, it is time to the power minus 3. Pressure or stress is given in what we call pascals, which is a force over area, newtons per meter squared, Remember, Newton is kilogram meters per second squared, so it's kilogram meters per second squared divided by meter squared. So that gives us kilogram divided by meters times second squared, which is kilogram meters to the power minus 1 seconds to the power minus 2, which is, in dimensional analysis, m L to the power minus 1, length to the power minus 1, and time to the power minus 2. Finally, we have density, which is mass per volume, which is kilogram. Volume would be meter cubed, that's the SI unit, which is kilogram meter to the power minus 3, m length to the power minus 3.